Hey everyone and welcome. Let's dive right into today's explainer covering Caldwell 36. You might know this one by its nickname, the Koi Fish Galaxy. Now, if you were to just casually glance at it through a standard telescope, you'd probably think, wow, what a beautifully peaceful island universe drifting quietly through the void. But, as we're going to uncover today, this galaxy is actually a raging cosmic engine. It is literally full of explosive forces, hidden fountains, and entirely invisible companions. We're going to peel back the layers of this fascinating object and see exactly what's hiding out there in the dark. Just to ground ourselves in exactly how deep into the cosmos we're looking today, this spiral galaxy is located a staggering 29 million light-years away from us, over in the Coma Berenices constellation. At that immense distance, trying to understand the mechanics of how it functions means we really have to act like cosmic detectives, you know? We have to piece together clues from all across the electromagnetic spectrum.
So let's start with what we can easily see. Discovered by the legendary astronomer William Herschel way back on April 11, 1785, this optical view shows us a gorgeous SABCD spiral galaxy with a somewhat weak inner ring structure. It looks incredibly serene, right? But honestly, the most fascinating aspect of this optical view is what it's actively hiding from us. Visible light, the stuff our eyes and traditional optical telescopes can pick up, is only telling us a tiny fraction of the overall story. To see the true anatomy of the Koi Fish Galaxy, we have to change the way we look.
Which brings us to Section 1, the invisible gas halo, focusing on extraplanar hydrogen.
When astronomers used the Westerberg Synthesis Radio Telescope and later the HALOGAS survey to map out the galaxy's neutral hydrogen gas using the 21-centimeter radio line, well, they didn't just find a nice flat disk that neatly matched the starlight. Instead, the radio observations from the HALOGAS survey revealed a really stark contrast. On one hand, yes, you have a thin, regularly rotating cold gas disk that corresponds nicely with the visible spiral arms. But on the other hand, hovering vertically both above and below this disk, there's this thick, anomalous layer of gas. And crucially, this thick layer is lagging. That basically means it's rotating significantly slower than the gas down in the main disk. It is a completely distinct, kinematically separate structure.
Now, it's absolutely crucial to understand the sheer scale of this anomalous layer we're talking about here. This invisible, lagging halo isn't just some trace amount of accidental cosmic dust. No way. It accounts for an astounding 10 to 20% of the galaxy's entire hydrogen mass. We are talking about hundreds of millions of solar masses of gas just suspended high above the galaxy's main disk.
Okay, moving right along to Section 2, galactic fountains and forbidden gas. Let's talk about how this stuff gets pushed out.
Because think about it. It takes a monumental amount of energy to lift millions of solar masses of gas against the gravitational pull of an entire galaxy. The clues to solving this mystery actually start with a massive void. Researchers peering into the radio data found an enormous, totally empty hole in the hydrogen gas layout on the galaxy's approaching side. And to be clear, this isn't just some subtle dip in density. It is a giant, sweeping cavity demanding an explanation. So what violent event could have possibly punched a hole this large and swept the whole area clean?
Well, the prime suspects are all rooted in the life cycle of stars themselves. When regions of a galaxy undergo periods of really intense star formation, massive young stars generate these fierce stellar winds. Then, when those massive stars rapidly die, they go out in explosive supernova events. When you have these things happening in dense clusters, their combined energy creates what astronomers call a galactic fountain. Basically, this fountain acts as a colossal cosmic geyser, blasting surrounding gas violently upward and outward into the halo, effectively carving out those massive holes we observe.
And this visual brilliantly illustrates the aftermath of that chaotic process. Notice the blue circle here marking the location of that massive hydrogen void we were just talking about. Right below it, pointed out by the arrow, is a filament containing roughly 1.4 million solar masses of what researchers call forbidden gas. It gets the name forbidden because it's moving at velocities that make absolutely no sense for the normal rotation of the disk. Analysis suggests that this massive filament is violently outflowing on the far side of the disk. It's a direct, measurable consequence of a raging galactic fountain erupting straight from the galaxy's plane.
That leads us into Section 3, the cosmic thermostat. Let's see how this macro-level violence builds up from an intricate microscopic engine.
So, the crazy gas dynamics we just looked at are ultimately driven by star formation. But star formation itself is heavily regulated by how efficiently the interstellar gas can heat up and cool down. To understand this thermostat, we have to introduce a microscopic player, polycyclic aromatic hydrocarbons, or PAHs for short.
These are tiny, complex carbon-based dust molecules floating all throughout the galaxy. You can kind of think of these ubiquitous PAH molecules as the galaxy's solar panels. Their main job is capturing intense ultraviolet photons emitted by young, hot stars. Here is how that microscopic engine actually operates step by step. Step 1, those young stars emit intense UV radiation. Following that, in step 2, the PAH molecules absorb this radiation and eject photoelectrons out into the surrounding space. For step 3, these super fast-moving electrons collide with other particles, which powerfully heats up the surrounding neutral gas. But a thermostat can't just heat things up, it has to cool them down too. So in the final step, step 4, carbon atoms in the gas become excited and emit far-infrared radiation, specifically through what's called the CII fine structure line, which escapes into space, effectively cooling the gas down. This cycle is absolutely crucial. It determines whether gas clouds are going to successfully cool and collapse to form the next generation of stars, or if they'll just remain way too hot to condense.
However, observational programs have revealed that this delicate thermostat isn't completely indestructible. In regions with extreme star formation, the radiation field can become incredibly intense. This leads to what's known as the far IR line deficit. The radiation gets so fierce that it actually ionizes the small PAH dust grains, essentially breaking the galaxy's solar panels. When that happens, the heating efficiency drops and we see a measurable deficit in those vital cooling lines. The galaxy's internal engine starts to stall out simply because the environment has become too extreme. And this matters immensely because it limits how fast a galaxy can actually grow. It's basically nature's built-in way of preventing the galaxy from burning itself out too quickly.
Finally, Section 4, a hidden dwarf companion lurking in the halo. Let's zoom way back out.
Zooming out to about 58 kiloparsecs from the galaxy's center, the deep radio data reveals yet another incredible invisible secret. Astronomers detected this massive, completely isolated blob of hydrogen gas lurking out in the gravitational periphery of Caldwell 36. We're talking hundreds of thousands of solar masses of material, and it's completely unbound from the main galaxy itself. If you were to look at this exact spot in standard optical surveys, you would see absolutely nothing. It is a total ghost to traditional telescopes.
But when researchers cross-referenced this radio blob with optical data from the Sloan Digital Sky Survey, a totally shocking reality emerged. These distinct emission lines popped up, signatures of high excitation HII regions and young stars. This isn't just some lifeless, boring cloud of gas. This invisible blob is actually two merging blue compact dwarf galaxies currently undergoing a starburst event. They are completely dwarfed by Caldwell 36 and nearly invisible to us, yet they are dynamically merging right next door at the exact same redshift.
Which really brings us to a profound realization today. We started this explainer by looking at a serene, beautiful optical image of the koi fish galaxy. But by diving deep into the radio and infrared data, we've revealed a system defined by violent galactic fountains, millions of masses of forbidden outflowing gas, microscopic thermostats breaking under extreme radiation, and totally invisible, merging dwarf galaxies hiding out in the dark halo. It leaves us with a truly fascinating question to ponder. If this seemingly tranquil galaxy hides such raging cosmic storms and invisible secrets, what else is waiting to be discovered out there in the dark corners of our universe? Thanks so much for joining me on this explainer today, and as always, keep your curiosity aimed at the stars.